Hello students, welcome to EPG Pathshala. I am Dr. Aditya Tripathi. I am assistant professor at Banaras Hindu University. In this module, we will be talking about physical organization of data on storage devices. This topic or this module is part of paper information storage and retrieval. In this module, we will be covering about data storage in storage devices. Then we will be also talking about different kinds of storage mediums we use for data storage, as well as we will be talking about data representation on these storage devices, how the data is represented, how the data is stored on these devices. We will be also talking about physical and logical representation of data on these data storage devices at the time of data storage. Normally data is stored in kind of files in data storage medium. So we will be discussing about data files and their different types. Data is stored in two forms, that is sequential and non-sequential manner. And in non-sequential manner, the most important is hash file organization and binary file organization. We will be discussing in detail in this module. Coming to data storage in computer, as you know that computers are normally used for processing units. Not only that, these machines have capacity to store data in different external data storage devices. So physical organization of data is for storing the data on different storage devices, so that data is retrieved for application with minimum latency time. So most important or the underlying part of it is the data should be retrieved with a minimum latency time. There should not be time delay between request and the retrieved data from these physical storage medium. Then coming to data storage, these devices have data storage facility. Normally, the data stored is in the form of non-volatile storage in these devices. Non-volatile storage is normally we say that when we switch off the computer, the data is still retained on the devices. There are two kinds of storages in the computer. One is volatile storage and other one is non-volatile storage. So here we will be talking about non-volatile storage. Then the second point is large quantity of data is stored on these devices. On these non-volatile data storage devices, you can store gigabytes or terabytes of information, and data is stored on external memory or secondary storage. Normally we call these kind of devices as external memory or secondary storage devices. In computer, the data is stored in the form of hard disk. Normally we have hard disk, we call them internal hard disk. Nowadays we have external hard disk associated with the computer, so that we can port the data. Data is also stored in form of optical storage medium like your CD, DVD or Blu-ray disc. You have flash drives or pen drives, we call them flash storage nowadays, to store the data, and we carry this data in our pocket. Besides, we have tape drives, which is an example of sequential storage for data storage for long-term data preservation. Data storage on hard drive. This is the diagrammatic representation of a hard drive, typical hard drive a computer has. You can see in this image we have series of disks put on a spindle, uh, one after other, and these disks have these disks have sectors and cylinders. Then each disk has one dedicated read and write head through which the data is written on the disk. So any data which has to be written on the disk, it has to be done through the dedicated read and write head. Data storage on optical drive. We have several optical drives or the options like CD, DVDs and Blu-ray. In optical storage device, the data is written in the form of a laser beam. Here you can see the laser beam is thrown on the disk through which passes through certain lenses, and then data is written on the disk. When the data has to be read, these laser beams are thrown. The head actually is a laser beam which throws the data, and the reflection is read by the detector, and it is transformed into electrical signals. Data storage on a flash drive. Nowadays, we are using often pen drives. This is the diagrammatic representation of data storage on a pen drive. Uh, at the top, we have plastic. Under that covering, we have an insulator of made up of resin. Below this, we have actual NAND EPROM, which actually stores our data, which contains the circuits, and at the bottom we have a contact unit which transforms data from NAND EPROM to the outside devices, or take the data from outside devices and stores it into the storing unit. Data representation. In computer, data is represented through electrical signals. So whatever data we store in the computer, it is form of electrical signals, and these electrical signals are represented as a binary system through symbol of 0 and 1. So any character, if we are representing in the computer, it can be represented in binary system as the series of zeros and ones, as the example shows for you. A representation of character A as the series of zeros and ones in a binary system according to ASCII table. ASCII table is a standard table for the characters and their respective decimal values. Data hierarchy. This is actually showing you the logical structure of a database. Here you can see there is a computer. Inside computer, in the computer we have database. A database can have several files altogether, and each file will have different records. And in the hierarchy we have fields under records. That means each record contains several fields, and these fields actually store the values. It is in the form of bytes, and ultimately the representation of characters in 8 bits. This is physical representation of data in a database. Here you can see that the red bordered is the database. Inside this database we have several files. Then the files have records in it, and then you can see in the records we have several fields. These fields contain the value in the form of characters or words, and these values actually are stored in the form of bytes and bits. Files. A file contains data that is needed for information processing. A file can be about any object like person, concept, physical object, or event, or anything. In computer, any data is stored in a form of a file, and each file has certain assigned names. These files actually contain the data, which are nothing but they contain the byte sequence, which ultimately is read by certain application software and creates a meaningful display for us on screen or any kind of output device. So the smallest unit uh, which can store the data is file in our computer. There are different kinds of files in the computer, especially in the databases. We have master files, we have program files, we have transaction files, we have report files, and we have backup files. These all files play different kinds of role, and that is why they are given different names. In the next few slides we will be discussing about these different kinds of files and their roles. Master file. Master files are main file which contains the data for long-term storage, which can be read afterwards once it is stored. Uh, in a database management system, the actual data is stored in the master file. For example, in CDS-ISIS database, we have a file with an extension .mst. which stores the actual data. Normally, this data is stored in a kind of a binary format in CDSIs. Program files. Program files are the files which are the part of a database management system. These files contain instruction or processing information. Normally, program files are the actual programs or the part of the software which contains the processing instructions, how a particular activity has to be done. Say, for example, you want to add a record. The instruction or the way a record has to be added in the database is written as a program and it is stored in a program file. So any kind of data manipulation or data processing activity is governed by program files of a database management system. Transaction file. Often when we work with any database management system, we perform certain tasks, many activities on the database management system. These database management system create a lot of temporary files. So these files are used during the processing period of data processing, and often these files are deleted once the process is over. Particularly if you see CDSIS database management system in library parlance, when we do indexing process in CDSIS, it creates certain level of index, different level of sorting, and it creates many files in between. These files are normally transaction files created by CDSIS database management system. Report files. One of the major application of database management system is generation of reports. We can create reports, we can generate reports based on our needs. In order to create reports, we can shoot query on the database management system and it generates reports. For example, in a customer database, you can create list of customers, you can create bills of customer, you can create statement of transaction, and so on. So report files are very important files which are actually used as output of database management system. Backup files. These files contain data that will not be lost in the if the original files are damaged or destroyed. These files are very important files in case of any mishappening with hardware, software, or system breakdown. The recovery is done by these backup files. Often these files are created online as well as offline for our rescue purpose. Data storage. So far we have seen different kinds of files generated by the system. Now let us see how the data is stored on a storage medium. The data which has to be written on the storage medium normally resides on main memory of the system. Then the system passes an instruction through the software or through the application software uh, to store the data on the medium. This instruction is given to the head, which is the device to read and write. This device actually places the data on the storage medium at appropriate place. Record structure. One of the important thing about data storage is how the record is stored or what is the structure of the record on the device. Basically, structure is where all the elements of a record are arranged in an organized manner to provide a structured record. Structured data is nothing but it is, we call it as record in a database management system, and it is the simplest form of data collection whose meaningful organized form gives a meaningful data. A record structure normally consists of length of character, number of files, each record with a length indicator uh, used as an index to keep track of address, and place a delimiter at the end of the record. Record structure. Here in this slide we have presented the record structure in ISO 2709 format. It is an exported format from a CDSIS database. Here you can see the record has three parts. The first part is known as leader, which contains the information about the length of the record and the maximum size of a particular field. Then the second part is the directory structure. Directory structure resembles to our content page of a book. In directory structure, the field number is given, then the length of the field is given, and the starting character position of the field is given. Then the last part of the record is the data field, where actual data is stored. Data organization. The data is organized on storage medium by two methods. The first one is sequential organization of data. Then the second one is direct or non-sequential organization of data. In the next few slides, we will be discussing in detail about sequential and non-sequential organization of data. So students, as we know that there are two kinds of data organizations. We have sequential organization and then we have non-sequential organization. Coming to sequential organization, as you see that in sequential organizations, records are stored and retrieved in a sequential manner. That means there is a sequence of records, a serial number of the record, and records are stored serially in a sequential manner. That means one after another. It is ideal when most of the records to be accessed for processing. Sequential organization is normally it is very ideal when you want to access a particular record, and in order to access particular record you have to access all the previous records. For example, if you take a book, in a book if you have to access a particular chapter or particular page, you scroll through book. You cannot just jump on a particular page. So such kind of organization, we call these organization as sequential organization. Then in this organization, data is retrieved in sequence, and that way it is stored. So for retrieving the data, as I took the example of book, you are retrieving the data also in a sequence. That means any searcher or any person who is uh, accessing a particular record, he has to go through all the previous records. That means he is going through all the chapters, all the data previously stored before this record in the sequence. Then next point is records are stored in some predetermined sequence, one after another. Normally it is done based on a particular key. We call this particular key as primary key, which determines the sequence of the order. A primary key is a field in a database whose content is unique in the record. That means the primary key is a unique field, and the value of the field is not repeated in any other record in the database. That means because of this primary key, we can determine the organization, we can determine the sequence of the record. An example of sequential storage is tape drive. Normally you have seen the video cassettes or audio cassettes. These all are examples of sequential storage. Sequential organization. This slide shows how the data is stored in sequential organization. Here we have data about books, about its title, author, publisher, and year of publication. You can see at the left hand side we have a column named primary key. These numbers are unique. You can see that it is 101, 102, 103. This key actually determines the sequence of record in a serialized manner. So this kind of organization is known as sequential organization. Sequential organization has several benefits to its credit. The most important thing is it is easy to understand. As you know that data is stored in a sequence one after another. So while reading the data, it is easy to read a data, and we can understand the organization more easily. The second point is long-term storage. The devices on which sequential organization is managed, the life of these devices are more, say for example magnetic tape, which has more life, and these are mostly store data as backup purpose. Then we have these devices are least expensive method of storage. The cost of these devices over which the sequential storages are done, they are least expensive or cheaper compared to other devices. The data organization and maintenance over these devices are easy. Then in case of any errors, finding the error, detecting the error is easy on these devices, as we can read the data one after another, or we can move across the media to find out the error, and that way it is easy to localize any error in such kind of media. All over, these devices are good to keep backup for future use. However, there are certain shortcomings with this kind of sequential organization. In sequential organization, if we take disadvantages, we see access to a particular record may be too long for many applications. Since if you have to read record in a sequence, it takes more time to read a particular record, particularly if the record is last in the sequence. So you have to cross all the previous records to access that particular record. So it takes more time while reading on a sequential storage organization. One record updation requires entire file to be processed. Say for example, if you want to update a record in a sequential organization, you have to cross or you have to bypass all the previous files or all the previous records just to reach the particular record you desire to update. To access one record in middle, entire records before the record has to be accessed. As previously I have talked about that if you want to access a particular record in between, then you have to cross all the previous records to reach to that particular record, and therefore accessing the file may take time for us. Not only that, if you want to do random searching on sequential record, it is very difficult. So students, so far we have seen sequential file organization. There is another kind of file organization on the storage devices. We call this kind of organization as direct file organization or non-sequential storage. In this kind of a storage, the data is accessed randomly. That means the data is stored in a random order around the storage devices. Then this stored data is the address of this stored data is stored in a kind of a table. It is just like the content page of a book. Uh, then that means this direct in the direct file storage, if you want to search a file, you don't have to browse through whole file. Rather, you can directly access the data from the system. It is just like that in a book. If you want to access a particular topic or you want to access a particular chapter, what you do is you go to the content page, take the chapter topic, and then directly you go to that particular page number. You don't browse page by page of the book. So direct access is a kind of a storage where you can directly access to the information which is stored the device uh, on the device at different locations. Then there are two kinds of storage we find in direct file organization. One is hash file, or in other words we call it as index file organization, and the second kind is B tree, or we call it as binary tree. Hash files, this is one type of file organization under direct file organization. Here, the records are placed randomly over the storage medium. Here, a field is recognized as hash field among all the fields. Hash tag is generated from the hash field. So once you recognize the hash field, the system performs a kind of calculation, a hash field, and generates a kind of tag which is known as hash tag. Hash tag is used for storing the files on physical medium. This calculated hash tag is used as address for the file which is to be stored on physical medium. So this hash tag is the address of the file uh, on the storage medium where it is stored. Then an index is created with hashtag to locate the file as record. So this index actually what it stores is it stores the key term and the hashtag value. The hashtag value is nothing but it is the address of the file to be located on the storage medium. This is a diagrammatic representation of hash file organization. Here you can see at the right hand side we have several records with different fields like employee ID, last name, first name, salary and contact details. On here you will see that on the field employee ID, the system has created hashtags and it has created certain values from the employee ID field, and these values are to some extent these values are unique. So you can see the hashtags generated for different records 24, 25, 26, 27 and 28, and the location, this hashtag is used as the location of the file stored on the media, and this is actually a hash index which is used for locating the record on the storage media. B tree, commonly called as binary tree, it is basically a tree like structure which is made up of nodes. These nodes are actually the values or the pointers to access the files. Each node is connected with two or more child nodes. That means each node can have several children. The left hand child node carries lower value than the top node or the parent node. If there is a parent node and it has several child nodes, the left hand side child node carries the lower value than the parent node. Similarly, the right child node carries higher value than the top node or the parent node. So the right side of the right arm of the parent node contains the value higher than the parent node. The order of the tree suggests the maximum number of children a node can have. Normally what happens is in binary trees we define order. The order actually represents how many children one node can have. Say for example there are we define order 4 in a binary tree. That means any node can have maximum 4 children altogether. That means that particular node cannot have the fifth child in that under that particular node. This is an example of binary tree of order 4. Here you can see that the parent is or the root node is 17. On the left hand side we have two values 3 and 8 which are smaller than 17, and in the right hand side we have two values which are greater than 17, that is 28 and 48. In the left hand side in the further branching we can see that the node 3 has two values, that is 1 and 2 left to the node 3. Then we have node 8. To node 8 we have two values to its left, that is 6 and 7, and to its right we have 12, 14 and 16 which are bigger than 8. Similarly, we can see on the right hand side we have two values 28 and 48. Then to the left of 28 we have values 25 and 26, and to right of it we have 29 and 45. 29 and 45 is placed to the left of 48 as it is smaller than 48, and 52, 53, 55 and 68, which are bigger than 48, they are placed to the right hand side of the 48. The maximum children any node can have in this table is 4. That means this table is order 4 table. This is another example of binary tree. Here alphabets are placed. You can see in this we have at the top node A, then to left of it we have B, and then C, and further D, and this branching is extended as the tree grows. So this is another example of a binary tree. Direct file organization advantages. We have several benefits to direct file organization, as we know that many of the day-to-day devices, storage devices we are using, they follow direct file organization. The advantages are records can be accessed directly and quickly. In direct file organization, as you know, you can immediately access any record or file, and it is very fast. Primary and secondary indexes can be used to search for data in many different ways. Updation of direct accessed file or non-sequential file organization is very quick. One need not to bother about record order in this kind of file organization. Adding, deleting or manipulating the record is fast in direct file organization. Centrally maintained data can be easily updated. Disadvantages of direct file organization. One of the major difficulties we face while using hashing algorithm is hashing algorithm collision. Often when we calculate the hash tag, if the value is unique, there is no problem. The problem comes when the hash tag is calculated for two records and those both hashtags are same. In that case, there is a collision, there is a kind of a problem of the values, how to place the values. In that case, the system creates a secondary index kind of thing to resolve such kind of problems. In these kind of binary trees or in this kind of hashtags, if similar keys are there, there is always difficulty. But if these with these systems we generate more number of indexes as secondary indexes, as we pointed out in hash algorithm collision, that we generate a secondary index to store the second hash value. If you create more number of index, your efficiency of the system is compromised. It is not advisable to create many index with direct file organization systems. So in this module, we have seen that computer is a kind of electronic device which can take input and generate output, and this output is stored in a kind of different kind of storage medium. So we have different kind of storage media where we can store information. In this module, we have discussed about different data storage options like hard disk. We have optical storage medium in the form of CD, DVD or Blu-ray disc. Nowadays we are using flash drives with different kinds of memory capacity, storage capacity. So as pen drives, we popularly call them as pen drives. So these are some options of data storage nowadays we have. So we have discussed in this module how the data is stored on these different storage devices and retrieved. Then we have talked about how the data is stored on these devices in the form of binary system. We have also discussed about the record structure of a database management system where data is stored in in a record. We have also discussed the logical and physical organization of data in a database management system. We have discussed how the data is stored in a hierarchy. We also discussed in this module different files, because files are the entities where we store data normally in a computer. So we have different kinds of files, and we have discussed different kinds of files in this module. Besides, we have also discussed different kinds of file organizations, including sequential and non-sequential file organization. We have also discussed how you can construct a hash file organization, or how hash file organization is done in the computer. We have further discussed the binary trees, how the data is stored in the form of a binary tree, how the binary trees are constructed, and so on. So overall, this module presents and gives you an idea at the end that how the data is stored and how the data is retrieved from a storage medium.